Today we're going to do something a little different from the last two and take a moment away from the game engine in game. Instead, I'm going to quickly go over the equipment I use to work in DOS and capture it. And then we're going to go over two very helpful tools that bridge my DOS projects with my modern computing. So don't worry, we'll still have a little programming today. Okay, first, let's just head over to the workshop. Well, I've always had a soft spot for DOS games, PC games from the late 80s, the early 90s. It wasn't until last year I got the itch, the idea, to try to dive into and try to make my own stuff using period-correct hardware and software. Fortunately, hardware is plentiful on eBay, so I was at first able to pick up this machine. She's named Bow, after Laura Bow, and it's a Pentium 75 with 32 megs of RAM. There's actually a couple more in the collection: Graham, a Pentium 4, Jones, a VIA 7, and Laffer, a 486 DX66, but we're not focusing on those guys today. Since I did give her some modern updates, I'm not strict about this period correct stuff. She has two CF to IDE readers that the machine picks up as IDE drives. Additionally, there's a Pico Gus. It's a pretty cool Pi Pico driven ISA sound card that can emulate various period sound cards, and an ISA 3COM 508 network card, which, more on that guy later. Of course, I did need a clicky keyboard from the era. I was able to also score this Dell 17-inch CRT for ridiculously cheap on eBay, opting for a CRT experience over a VGA LCD monitor. And the last two to talk about are the converter and capture device, which I think could be some interest to people. It took me a bit to hunt down something that would actually convert VGA to HDMI. See, the main issue is that VGA's sync and resolution aren't normal. So you can't just go straight VGA to HDMI. You need something to convert the signal. I at first tried this convoluted VGA to component to HDMI setup, but I couldn't get the display to be anything other than pink. Giving a GBS-C converter a try, it almost worked, but it was shaving pixels off the left edge. When I finally got the H-Sync to work so it would show the pixels, they were dimmer than all the others. So I tried one more thing, this Kaiko OSSC 1.8, which that was the winner, and that's what I'm using now. Combine that with the Elgato HD60X, it works perfectly fine for me. It's available on Amazon too, so I'll link it. That's it for my hardware setup, so I'm going to talk about a couple tools I wrote that make up part of my software setup: Bowtie and Bown. Bowtie is a tool I wrote to bridge DOS to a Git repo. Remember that 3COM card? Well, here it is. With the NIC installed, I'm using a DOS TCP driver called WAT TCP to connect to Bowtie's Python server, which runs on one of my modern machines. A simple config file matches a project name to a local Git directory on the machine, and then from DOS, Bowtie connects to send files, retrieve files, commit, push, and pull. And it's all through a simple REPL prompt, so you always know exactly what you're doing. And why would I do such a thing? Well, mainly I got tired of swapping a CF card around, and plus the CF card reader pins are pretty fragile. And to wrap up today, I'm going to explore one more tool, Bown. You may recall in the previous videos, creating class files rather annoys me with Borland C++, so Bown's going to handle that for me. A simple command line tool that generates a header and a CPP file in a given directory, preset with a header guard and an empty default class. Bown will be written in C for two reasons. It's a dead simple tool and will be super fast this way, but also I have very little experience using C, so it's a perfect small project for me to practice with. Okay, so by default, Bown will make a class when I pass a relative directory as the first argument, and the name of the class as the second. I'm going to set it up so I can pass a type first, which right now is header or class. Header making only the header file, class being the same as the default if I don't use the type. The only header type is useful for things like template classes, but also if you want to do a file full of definitions or macros to share across a couple systems. Bown isn't a complicated program, so it's really just made up of three main functions to create any directories that don't exist, write the header file, and write the class file. The majority of the program is rather rote text formatting actually, but we'll still dive into it a little bit. A quick gotcha for me, coming from C++, and without a C background, is that in the original C8990, you must declare all your variables at the tops of the functions, or actually at the tops of scopes. In the C99 standard and later, this is no longer a strict rule, but during this period of time, it was. Before I can write my header or CPP files, I need to make sure they're placed in the right directory. So since standard IO's mkdir only creates a single level at a time, I've got this helper function. It maybe makes a directory because it's valid to call in directories that exist. It just won't do anything. So instead of calling mkdir just once, this function will seek each directory name in the past relative path and make each directory that needs to be made. Writing both the header and CPP come with no surprises, really. The only thing to watch out for is that I don't have the memory safety of modern C++ that I'm used to, having to ensure that I don't overflow buffers writing strings. Other than that, it's pretty straightforward. To avoid one potential gotcha with auto-generating the classes, I do create them with virtual destructors by default. Having virtual and not needing it is far less potentially annoying than not having virtual and needing it. And since these files are auto-generated, it's a bit easier not to think about. With all the compile errors fixed, this is my final compile before giving it a test. Speaking of test, that's a good name for our first directory and file name. And I can see here a little bug not spitting out the create file or the new lines it seems, but checking the directory, we can see both of the new files are there. The last thing to check is adding them to my project and seeing what file contents look like. I know there's DOS-edit exists, but it's more fun this way. Well, the C++ file is correct and simple. And there's our header file looking perfect with our virtual destructor as well. That's it. Hey, thanks for watching. Next time I'm going to get back into the game engine as we're getting only a few episodes away from revealing what the game I'm making is going to be and starting in on the game code. Before that though, I'll be making a fairly simple sprite system and something near and dear to my heart, a UI system. This next one might be a bit of a doozy. Okay, love you, bye.